Okay, now it's your turn to have a go. So imagine you are standing on top of a building which happens to be on the moon, and the gravity of the moon is actually 1.622 something. But let's round this off to 2, just to simplify things. So gravity on the moon is 2 meters per second squared. Now, if you were to drop a cannonball, it would be it would look something like this. After well, this is t equals 0. So initially it's up here. You drop a cannonball, which happens to be on the moon. Um, uh, After 1 second, it will be here. After 2 seconds, it will be here. 3 seconds, it will be here. 4 seconds, it will be here. So this thing here belongs to this. So this is 4 seconds. Now I want you to well, draw the time, the acceleration time graph for the cannonball, and the speed time graph, and the distance time graph for the cannonball here. So the acceleration will look something like this. The gradient, the speed will look something like this. And to find out the distance, let's say to find out the distance at t equals 4. So remember, if you have an acceleration of 2 meters per second squared, it means the speed increases by 2 every second. Okay. Well, the hard part is finding out the distance. Use the speed time graph in order to work out the distance. So let's say this time is at 4 here. Okay. So what would be this height here? Well, this height, well, if you have an acceleration of 2, then this graph would be, well, y equals 2t, or s equals 2t. Okay. And then, well, put the 4 into the t here. So this speed here will be 8. So the height here would be 8. 8 after 4 seconds, and then the across here is 4, and then get this times this. That will give you a rectangle divided by 2, and then that will give you the distance. The hard part is working out the distance. Okay, and then when you come to do the t equals 5, maybe t equals 5. Maybe draw yourself a new diagram if you have to. So this would, what, 5 here would be here. The height here will be well, it will be, well, 2. Well, you would use this. You put the 5 into the t, and then it will give you y, and then the y really represents the up and down here. Well, draw yourself a new diagram, or you can use that whenever you have a free falling object, you can use this formula here: h equals gt squared over 2. G in this case is our gravity. Well, if I were you, remember this formula here. It's quite useful. Or do whatever you want. Either use this formula here, or use the speed time graph. For each second here, do this bit here. For each second, write down the t equals this, speed equals whatever, work it out, and distance, and then work out the distance. Okay. So for each one of them. So well, anyway, press pause and have a go. Okay. So t equals 0 here. The speed will be 0. The distance traveled will be 0. Okay, so that's D here. That's done. For t equals 1, t equals 1. Well, actually, I think we will need quickly sketch our acceleration time graph. So it will look 2 here. So that would be our acceleration time graph. Our speed time graph, it will be a straight line like this. S equals 2t. Sometimes I use y, sometimes I use s. It's up to you. And then and if you then you can do your distance time. Okay, so distance time. If you want to work out the distance at, let's say, 3, then work out the area at t equals 3. The area here will represent the height of the distance. Well, anyway, Let's try and do this. So at t equals 1, hang on, let me clear all this. At t equals 1, hang on, let me think, sorry. T equals 1, that will be, speed will be, well, speed here is 0, so the speed here will be 2, this speed here will be 4, this speed here will be 6, this here will be 8, 10, at this point here it will be 12. When it hits the ground, it's going at 12 meters per second. Okay, and then remember the acceleration is always 2. The acceleration is always 2, 2, 2, 2, 2. And if you want to know the distance after 1 second, well, hang on, the speed time graph after 1 second. Well, this will be 1. After 1 second, the height here will be 2. Yeah, after 1 second, the speed here is 2. Because remember, it's s equals 2t. So the height here will be 2. So it's 2 times this distance here, which is 1, and then divided by 2. 2 times 1 is 2, divided by 2. So the distance traveled here would be 1 meter. Okay, and then at t equals 2, whether I've got to clear this, at t equals 2 here, the speed will be, hang on, 2, 4. The speed will be 4. The distance will be, well, s, t, the distance will be at 2 here, so the distance here will be 4. It will be going at 4 meters per second. The speed is 4, so the area underneath this will be 4. So it would have traveled 4 meters here. Okay, or you can use h equals gt squared over 2 to find out. Now at t equals 3, t will equals 3. Speed will be 2, 4, 6. Speed will be 6. The distance traveled, well, you would put the 3 into here. So that would be, or you can use the area underneath this graph here. I'm going to use this formula this time around. Put the 3 into the t, so that will be 9 squared. 3 squared would be 9, and then you times g here, which is 2, and then you divide by 2. So these two will kill off each other. So the distance will be 9. Okay, so distance at t equals 3 will be 9. Okay, I'm going to clear this up. I think I've done 4 for you earlier. So 5 here will be, well, the speed will be 2, 4, 6, 8, 10. The speed will be 10. Okay, the distance will be, well, I'm going to use this. Well, actually, I just feel like using the graph, so let's use a graph. S, T, the speed here, well, at time equals 5, so t equals 5 here, the speed is the speed is 10. Okay, and then basically get 5 times 10, and then divided by 2. So 5. So the distance traveled will be 50. 5 times this would be 50. Oh, sorry. 5 times this and then divided by 2. So it will be 25. So the distance traveled will be 25 meters. Okay. This times this will give you the whole rectangle, and then divided by 2 it will be 25. Now at time equals 6, that's when the ball hits the ground, the cannonball. So your speed will be 12. Okay, speed will be 12. T will be 6. The distance traveled, well, hang on. S T. What's this? 4, 5, 6. So time is 6. Okay, the speed will be 12. So it's 6 times 12, 72, and then we got to divide it by 2. So this would be 36. Okay, so the distance traveled would be 36 meters. Okay.